Thanks a lot. Thanks a lot for this invitation. When I discussed about this topic, I was very happy because, it's a topic related to giving a vision, but also giving an idea about what we did in order to drive our building as a key actor for the energy transition. We are speaking about energy transition, let's say, at different levels. And typically when we have the focus about the different sectors that can drive the energy transition, we have the general look in the civil sector, where the key role is related to building. Industry, I fully agree with the previous speakers. And then, of course, all the part related to the mobility sector. Here, our sector, so HVAC, refrigeration, and sanitary, is addressed to drive this transition with a specific focus on the potentialities of buildings. So, I start with the general picture. So, what is in Europe, but let's say also, let's consider Europe and the Mediterranean area, because when we speak together, and I speak together with my Turkish friends, we always think about to try to be the leader in this transition also in the Mediterranean area. So we have some specific steps to think about. One, of course, the transition, and here I am back to a sentence of the previous speaker. I fully agree. The transition is not only technological, it's a social transition. So we can help through technology the transition, but the key rule is related to the human transition. So we can involve in this transition the society. So the evolution is an evolution that is driven also through the use of new technologies, but it is addressed to the society. So first, we should try to use, to import less energy. This is a big political issue. All of our country would like to decrease the energy dependency from the, let's say, the surrounding world. And to do this, we have first of all to decrease the energy demand. Because of this is one of the first pillar. Our sector, that is the building sector, has the big potentiality. So we have to be very happy. Because as we know very well, we have, and this district is very clear, we have the new construction, but also we have the existing building stock. The existing building stock all around Europe, and here again, we have a poor energy performance of the existing building stock. So a major issue is related to the retrofitting of the existing building stock. Of course, the building sector play a key role, the mobility sector too, and we will see some similarity. Then, of course, another target that we have is to increase the use of renewable energy sources. This has the idea to have this integrated approach where we can reduce the energy demand, increase the energy efficiency of the technologies, and somehow integrate the residual and energy demand with a strategy where the renewable energy sources are a crucial actor. And then, of course, this very important sentence, we speak a lot about that at all the level, that is to put the human in the center. So, in order to have a society where people will use less energy, we have to increase the user awareness, and we have to drive a behavioral change towards a new way in using energy. I was a little bit curious about which are the drivers of change that are defined by the by the United Nations to drive our society to a post-carbon society. And I found out that there are lots of topics that are crucial in the document of the United Nations where the building sector has an important role to drive this change. Ranging from the optimization of the urban planning in terms of using energy as a key driver for the urban planning, up to the use of new material and new technologies in our products, up to use, as we said before, digitalization, automation, and service robotic for our activity. And then, of course, we have this big, and we have them here. This big change related to moving our design from the building itself up to the district, up to the city, so moving the idea of a new paradigm related to the building design from individual building up to a smart city, and then the use of the new IoT and ICT technology inside the building itself. So our sector can be really the driver of a change. I had the possibility to work at European level, and I tried to make a provocation about two different sectors, but in terms of transition, they are moving in the same direction, even if with different speeds. The mobility sector is pushing a lot the idea to a transition to electrical vehicles, introducing the ICT and IoT technology up to having an autonomous driving and or smart drivers. This is an objective transition to increase the use of electricity as the crucial vector in the mobility sector. At the same time, especially in Europe, all the policies that are now ongoing are moving the attention towards all electrical buildings, together with increasing the energy awareness of the final user, giving the possibility to the final user to have new tools and equipment related to building automation and to provide a smart and conscious approach of the occupants. So in somehow, these are two crucial sectors driving this energy transition that has some similarities. In my university, I serve my university as vice rector for research, so I have the possibility to have a look in a wide range of different research paths, but frankly speaking, I know very well that this is a transition. We cannot think about moving our sector to the, let's say, electricity, let's say, the full electrical concept, because frankly speaking, now we don't have the infrastructure to do this. And also because we have to think about new technology in order to drive this transition. So this, as a transition, we need time, but typically when you define a transition, you define also the path to develop new technologies. And frankly speaking, our sector has a rate of innovation that is not so high with respect to other innovation sector like the ICT and IoT that is highly entering the HVAC system market. Let's have a look about that, because this was also a plan that followed the steps that you had here in Turkey. We have always to remind what was the path that we had according to the introduction of the new directive and to the new laws at building level. We remember very well, and I know the situation here in Turkey very well, the first step was the introduction of the concept related to the building energy certificate. We worked a lot about that. It was, let's say, a sort of revolution. And this was an important step of this transition toward this post-carbon building. At the very beginning of this revolution, we had in mind that we have to solve an important question, that was the difference between the calculated energy consumption and the actual energy consumption. So what we calculate and what we obtain in the reality. Then we have a second step, that is the so-called recast of the energy performance of building directive that introduced two important concepts. One, this, let's say, transition towards the zero energy building. They put nearly, that's fine, it's a transition, but this should be the goal. But at the same time, we always had in mind that to drive this transition, we can not only speak about energy, but we have to understand the effect of this directive in the market. So are we able to design and to build buildings that are energy efficient, but they are suitable to be inserted in the real market? And this is why we introduce an important approach that is the cost-optimal approach that put together the building energy performance that must be analyzed together with the economical sustainability of our design. This was an important approach because to drive this transition, we have to drive the market. It is not only theoretical, but the market has to, a little by little, enter the idea to have this new concept of building and to have technologies that are ready to be applied in the market. Now, it's really an ongoing process. This month, in April, we will have the second recast of the energy performance of building directive. And in my opinion, the key aspect of the directive is to introduce the fact that we have at the very end to understand the real energy behavior of the building. So we have to put inside the building sensors to have a full-time monitoring system and to give information in order to have information in terms of technical information up to information to be given to the final user, and what I put here as interaction. So here we have different levels, the sensor level, let's say the monitoring level, then the data collection, elaboration, and storage, and then the feedbacks to the data. That is the big moment where we enter what I called here, okay, typically we are speaking about also before about factory or industry 4.0. In my opinion, we should also launch this idea of building 4.0 because this digitalization is a tool that must be integrated in our design. So the big topic related to the digitalization, I know very well, was introduced firstly in the industrial sector. Now, our sector, the HVAC system sector, has to drive this transition in the digitalization of the building because I'm a mechanical engineer, so I have clear this picture. The ICT sector is a tool, but we have to design the need of this tool inside our HVAC system design. So we are the leader, and they provide us a new, let's say, tool in order to better use during the operational phase our HVAC system. Very briefly, I said that this was really an important issue to drive the transition. That is, when we are developing an HVAC system, because again, I would like just to mention one thing. We have another transition in our sector from, let's say, the quality of the equipment itself up to the quality, to the performance of the system. Now, the HVAC system is a complex organism that has to work together with the building itself. So this transition and this optimization has to be done in order to have at the very end an energy performance that should move day by day towards a zero energy building, but should have the capability to keep the global cost at its minimum level. The global cost is, let's say, something that is clearly defined through the standards. We can, in my opinion, also criticize the equation itself because it takes only in consideration cost. In my opinion, where we are moving to a new kind of building, we are also able to increase the market value of the building itself. So we have not only a reduction of cost, but we have also an increase of value. I don't want to enter now in detail on this because it's a very, let's say, technical question. This is more related to the vision, but what is important is that when we are selecting an HVAC system, and now, as we know very well, we have different products to put together in order to create the system. What is really important is to have always in mind that this combination of the different systems will create two effects. An energy indicator, here it's primary energy, and a cost indicator, here it's a global cost. These are two crucial drivers in our analysis. So at the very end, to drive this transition, we have always to have in mind that we have to balance the energy performance and the cost analysis. I said, the cost-benefit analysis. There are lots of publications about that, so I don't enter in detail on that, but what, in my opinion, is important is that this equation, for the first time, entered the idea that we have to understand what is the period of analysis to calculate the global cost, because, of course, the problem is not only to understand what is the investment cost at the very beginning of the procedure, but, of course, which are day by day the running cost and, of course, the final value of the system itself. So typically, and this is the shape of the equation, here I have all the buildings that I typically call green buildings, so buildings that has now, in this very moment, a high investment cost, and the reduction of the running cost is not able to cover this big increasing of initial investment. Here is the area where now the market is able to set the minimum in terms of global cost. Here are the building where we have a low initial investment, but also very high running cost. So the idea is to day by day try to move this minimum in that area to drive the market and to be ready to accept zero energy building in the market itself. To To do this, it's easy because in our mental process, when we design, we have always combination of different solutions that typically are related to the building envelope solution in order to increase the energy efficiency, energy system solution, and integration with the renewable energy sources. So we have in mind this approach. This approach has two results, defining the energy performance of the building itself and the global cost of the building itself. So typically, and this is a typical metrics that we use, we define during our design process different solutions, and here we have in a residential building different possible solutions in order to provide a suitable indoor environmental comfort, from a very basic one that was a standard boiler, a split system, and without mechanical ventilation, up to an advanced one with radiant panels for heating and cooling, mechanical ventilation with heat recovery and dehumidification, and the water-to-water heat pump. And here, different level of thermal insulation and thermal inertia of the building. This possible matrix of solution creates, of course, different energy performance, but also different cost at the present situation of the market cost of the equipment. And at the very end, we always have a diagram like that, where different solution will create a different effect in terms of cost and in terms of energy. In terms of energy performance, this is a real example. But what is nice also, I always use this one to convince the investor that sometimes it is important to have a higher initial investment, because at the very end, during, according to the period of analysis, I will have, with the same global cost, very different solution in terms of primary energy. This is a zero, let's say, a zero energy building with the same global cost of this building that is around 50 kilowatt hour per square meter of primary energy. So this approach is an approach that can help the decision maker and the investor to drive in the right direction the energy selection of his HVAC system final solution. Very briefly, this is an approach, and then we have the new opportunity. The first one is that now we have a connected building. The building today, but especially tomorrow, will be connected. We will have different energy vectors entering the building, different energy suppliers. They will, we need to cover different energy needs, and we need to integrate what is produced inside the building itself to what we have to import and export to the building. I know very well that this challenge, typically, it is not only related to the individual building, but it's a challenge that we can play with the individual building at district level, at city level. So we are enlarging the idea of what is the context of our analysis. To do this, to be connected, here it is important the introduction of the digitalization. So first of all, we have to have in mind our design, and then we enter the digitalization. Because the digitalization, and here is ICT and IoT entering the HVAC system, allow us to have data. And data today, especially tomorrow, will be the key actor in order to increase the energy efficiency of the building. So to measure and to monitor, to give information and advices to the final user, but also to the energy managers, to integrate and to select the suitable energy sources inside the building, and of course to make or to increase the control and actuation inside the building. This is an important, I just mentioned this, we are also starting a new era where the HVAC system sector is deeply connected to the way by which the information is driven to the final user. Because typically the final user is not a technician, is not able to speak our same language, is a problem of communication. So we must provide data, and somebody should define the right way in order to define from KPI, so key performance indicator related to the energy behavior of the building itself, to have customized feedbacks to the final user in order to drive the right action to the final user. I did a good number of research projects on that. If you are effective in giving information, you can really drive the final user to act in an energy conscious way in managing its own building, because now the building is a very complex organism. Another question, the digitalization in our idea will solve the crucial problem of the last 15 years. That is what we call typically the difference between, or the big discrepancy between actual energy performance and calculated energy performance. Because we have, and I underline that, a lack of knowledge about the fundamental influencing factor that determine the actual energy use in buildings. Okay? The calculation of the energy performance is based on a deterministic approach. When you enter the reality, we have an enormous quantity of variables that are able to drive the actual energy consumption in a different way. This is a typical diagram that I show, where here is the distribution of a number of, let's say, identical dwellings in the same place, in the same area, with the same energy certificate, and this is the energy certificate said 90 kilowatt hour per square meter here, and this is the distribution of the actual energy consumption of those buildings. It's clear the actual energy consumption is related to the use of the building itself. So it is fundamental to make a solid monitoring approach inside the building design. I go to the end, and I finish the presentation with two sentences. First, why we must integrate the collection of data inside the building to understand the energy behavior of the building. Because, and who works deeply in these sectors knows this very well, in the very next future, the economical value created by the data connected to the energy performance of the building itself will overcome the economical value of the energy vector. This is the tendency of the market. Why? Because the business model is moving from paying energy used by the HVAC system to paying services provided by the HVAC energy system. That is the new paradigm of our business model, that I don't want to pay the vector itself, but the value is created by the services. Okay? As we know very well, the companies that now has the possibility to have this data are trying to lead this conversion of the paradigm. What is important in our sector is always to have in mind that when we decide to put a sensor inside the building to collect information related to energy, this building, this sensor must be part of a general architecture of the monitoring system. And to design the monitoring system is part of our knowledge, of our sector, okay? Because I want to avoid some situation where I was, when the approach of the people from the ICT sector is that, okay, we can put sensor everywhere. And that's fine, that's true. But I do not need sensor everywhere. I need sensor where I need the information that is suitable to have a final data that create an added value for our analysis. So we design the monitoring system, they provide the tools in order to optimize the data collection. So I think that we will have lots of activity to do. We can really be a leader in this transposition toward post-carbon building. And so good luck, and thanks again for this kind invitation.
Okay, welcome the first technical session of this symposium. The name of the session is Design Strategies for Mediterranean Climate. We have a task group in REVA, and we try to develop a guide for this subject. And in this first technical session, mainly we will discuss these strategies. And we have 3 invited lecturers in this session, 2 oral presentations, and we have 3 poster presentations. As you see, it is a very heavy schedule. So the time limit's very important. I would like to the speakers to obey these time limitations, and also they will leave or save some time for questions. To ask a question, you should proceed to the front of these microphones, aisle microphones, and then you can only ask questions from those microphones. So, to save time, I will not introduce the speakers. You can read them from the program and from the website. And it is an honor for me to introduce you the first speaker, Livio Mazzarella. The title of his presentation is Design and ZEP Strategies for Mediterranean Climate. The floor is yours.
Thank you for your presentation. I'm very glad to be here and to start this technical session. And I have a hard due just to try to keep your attention after lunch on the item of nearly zero energy building. Now, the main point is what does mean NZEB? Because still today we have problem to understand because there is a lot of similar acronyms. And you can see on the picture there is plus energy building, positive, net energy building, and so on. Then, before to start how we can design a nearly zero energy building, just to clarify what is the difference between the net zero energy building and the nearly zero energy building. Because just 2 years ago was coming out a report from DOE, Department of Energy, United States, redefining what they called before near net zero energy building, small n. We can see that they call it an energy efficient building where on a source energy basis, the actual annual delivered energy is less than or equal to on-site renewable exported energy. What does mean that? That if you look really to the definition, is not one point, is an infinity of possibilities. That means from 0 up to minus infinity. That is going to create some problem when we try to compare different systems, as you can see very easily with the next after this slide. On the other side, we have a European definition of N, capital N. The previous was small n, and Z, which is nearly not net, nearly zero energy building, which means that we have to try to design a building which is asking as few as possible, and this few energy has to be covered as much as possible by renewable energy. But this is then it's a limit which has to go maximum, ideally, to 0. 0 what? 0 not renewable primary energy, we will see later. Because the main problem about energy is that we are creating a bit of confusion when we have negative values for energy. We know that we cannot create energy, we cannot destroy energy, but then we have a kind of oil just below our building, and then we produce energy. Then, from the point of view of the European Commission, when they define their nearly zero energy building, as we have seen already in this morning, the idea was to move along an optimal cost path, to try what's the actual situation, the balance between cost and energy saving, which is paid by the market itself, and to move further to try to see what is sustainable for our community, for any country, from the economical point of view, to reduce what? The not primary energy use. What we have to buy, oil, gas, and other resources which are not continuously renewed. This is the main point. Then, if we have a clear idea about the difference between the net and the nearly zero energy building, we can understand what's the problem when I said it's not useful, the net zero energy building definition, because if you look at those pictures, you can see on the left side a certain building which is completely, let's say, served by photovoltaic system on the roof, and it's producing more than the needs, and exporting an amount of energy which is equal to the import of electrical energy from the network. And then you can say, is it zero, the balance? Because you produce more, export, and you import the same amount. This full electric building, the left one. The right one is the same building, same load, same everything, but I'm using an electrical driven heat pump. I'm just reducing the PV on the roof, and then I have again a balance. I'm exporting extra production of electricity from renewables, importing electricity from the grid. I have again the balance, is at zero, the balance. But of course, from this point of view, they are identical, they are zero both, net zero energy building, but they are different. One is without heat pump, the other one is with heat pump. And from the physical point of view, we know that the second is better than the first from the use of the energy. We are not reducing the potential of, for instance, solar radiation, because the great confusion today is that people say, well, energy from solar is free, it's renewable, I can waste that. No, you cannot, because the potential, the amount of power you can receive and can use is fixed. And then if you use in the bad way your surface for collectors, for PV system, later you don't have any more surface to use solar energy and so on. Then this is the starting point. What's the problem with the definition of European definition nearly zero? That it was left to the countries to define what kind of primary energy. And for instance, I have to say, I have to apologize, Italy was taking the worst decision, talking about total primary energy, which doesn't make sense. But we have to think only in terms of not renewable primary energy, the oil, the gas, and so on we use from depleting resources. Then, coming back to our point, how we can go through a good design of a building, I will use the acronyms MED and ZEB, just to distinguish from the and ZEB. And we can see that we have several important steps, which means we have, first of all, to try to reduce the demand, to work on the demand side. Then we have to use renewables as much as possible. But also, we have to consider the quality of the environment, which is sometimes missed in our decision, in our calculation. And also, education is very important. And finally, we can achieve our MED and ZEB, which focus on people satisfaction and health. This should be the first point, not to forget. Then we see that not only energy is the target when we are talking about at least MED and ZEB. Targets are also called IQ, indoor environmental quality, cost, because it should be affordable, and at the end, on the top, we have the people satisfaction and health. Because there are much more people, the end user is much more sensible to its own satisfaction, their own health than what I'm going to save today in terms of kilowatt hours. They're not sensible to that. Probably if you talk about euros or liras, Turkish liras can be much better. And as I said, the challenge here is that on one way we are moving from higher consumption of not renewable primary energy, trying to lower this using, of course, renewables and energy savings. On the other side, our goal is to increase the indoor environmental quality, which are competing factors, to try to maintain the cost at the acceptable level. Then you can see that if you just try to increase the comfort in a standard way, you're going to use much more energy normally. The challenge here, as I said, is try to compress the energy requirements, the energy use, but at the same time increasing the comfort. Then this is a known parameter, so the action normally we follow. I said this is the path to continental and ZEB, because you can see that mainly the focus is made on the integrates passive solar design, improve building envelope, which normally means put more insulation and reduce interior demands, heat, power. But what we have to think that we have to change in this way for Mediterranean areas, where integrated passive solar design means, together with free cooling, with how I can use the building fabric to reduce the summer load, not only to reduce the winter load, or how I can balance both, which is the major issue we have, because also in Mediterranean countries we have a region which are at a certain height or the sea level, and then we have a cold winter, a very hot summer, and then we have to try to balance different requests. Then we have, you see, improved building envelope. We don't have to insulate too much. We will see this discussion later. If you put too much insulation for a summer situation can be very worse, because we are not able to discharge the building from the internal load during nighttime. At the same time, you see that put there increasing comfort. Increasing comfort is our keyword. We have to reduce energy, but increasing the comfort, not reducing the comfort. And cooling, not only heating, cooling today is a major requirement. And finally, we have the power. Then we don't have to forget that due to our history in Mediterranean area, we have a lot of old buildings, and we would like to maintain the fashion of the old town. Then we have a lot of renovation, rehabilitation, retrofit. You can use the word you like. And then we can also go to NZEB, Mediterranean NZEB, trying to feed the building with renewable networks, for instance. Then there is a challenge also there, not only on the building, but on system, on area system like networks or renewable system, not only electrical as in this case, but also thermal eventually. Depends on the cost, always. We are engineers and we have to face the problem of the cost. Then, key issue. What are? The key issue is right ventilation strategy, for instance, of course, free cooling for summer, relying on set or passive option for the building envelope, but we see there thermal mass activation, window sizing, and so on. And heating demand can be, again, an important demand also in Mediterranean areas. High solar energy potential, that means we can use photovoltaic system, hybrid photovoltaic system, heat pump with solar photovoltaics, and so on. Depends on the cost. Time by time, we have to check always the cost. What we can say that solar thermal with absorption or absorption heat pump is out of the, let's say, convenience hub today. We will see in the future. Then, of course, we have a lot of natural lighting and then management of the artificial lighting using, of course, natural light is very important. Additional key issue that we said for MedZeb is indoor environmental quality. Okay, I will continuously remember this point because this is a very important point in my opinion. And another very important point is education. Education of the user, because as I said before, we had several experiences in the past that the final user say, well, I have a nice building using a lot of renewables, then I can leave open the window because I can waste. No, you cannot. This is the point. When education is very important. Now, the following criteria has to take into account, especially for our NZEB, we say IQ strategy must be designed at the same time as we are looking for energy strategies. I cannot decouple. I need an integrated process of designing. Also, passive and cooling strategy must be combined because we have a unique building, a unique envelope, and then you can have different envelope for summer, for winter. Energy strategy must take into consideration not only the heating season, the cooling season, because we know that in Mediterranean area we have large intermediate season where the system is not working, but still we need comfort. Again, indoor environmental quality. And then we have to design the building to guarantee the comfort also in that time. Existing strategies for colder regions should be not transferred without upon the benefits, because this is, I remember when I was young, and I have white hair here, that a design, passive design from Norwegian was moved down to Italy and south of Italy. And then we say normally that we have been able to cook eggs during the same time just putting inside the building. I mean, you cannot. It's a design which has to define locally, taking into account the characteristic of the land, the weather, and not only the weather. The heating demand can be, as I said, still the highest relative demand. That depends, as I said, on the location. Now, this is very important. We will stress again, a study on the implementation of local energy from renewable source is needed. What I mean with that? I mean that we'll see later that I have to see what is available on my site. Now, you can see here a nice picture giving the steps for MED and ZEP design. You can see several stages, starting from planning, boundary condition and diagnosis, design, companies consulting work, reception of the work, and finally user and maintenance. Because the design is comprising all these phases. We cannot just think about on the drawing table, making a design and sizing a system. I have to discuss with the other actors, I have to explain how to use the system, I have to deliver in the correct way the system, and the system maybe has to monitor the first year to understand if everything is going well. Well, so-called commissioning procedure, we will hear in this conference later on about commissioning. Now, going fast through what we have seen before, it's very important at the beginning, when it's planning, that a right group, that means a right team of people has to be collected and put together, from the architects to the engineer to the constructors and so on. Because the integrated design is a key word that we have seen. We cannot decouple all the pieces and put together. It's not a linear system, okay? We had then several issue collaboration, multidisciplinary team, and so on. Then systematic monitoring, et cetera, because if we take care of all possible issues from the beginning, this will cost much less than trying to repair at the end when we realize that the things are not going as we hope. Then, boundary condition, what does mean? It means that we normally think about the weather, no, but it's not only a matter of the weather. We have to look at the potential, we say, of the renewable energies. What I mean, for instance, I cannot plan to have a nice wind power generator if I have no wind. Or I cannot rely on solar if I have a few solar radiation because I'm in a valley. And then the solar is just seen for a few hours a day. Doesn't matter the latitude, and so on. Then I have very real local constraint. We have to answer all these questions, try to understand what we can use, what we can do. Then for renovation, of course, if you are moving at the renovation field, we have to think that we have to carefully understand what we have, in which context we are, from the architectural point of view, from the artistic point of view, from the social point of view, and so on. Then you can understand that you have very integrated design with people from conservatories and so on, trying to understand what you can do. And of course, energy audit, but not only energy audit, as stressed again, IEQ audit, indoor environmental quality audit is very important, because I can save a lot of energy if I'm putting back people in caves, but there is no comfort in caves. Then, when I'm designing the MEDZEP, I have to analyze the potential, the resources I have, the renewable local energy resource, trying to optimize and to make the choose, utilize the most effective from the cost and energy point of view. And in the science, very important, as I said before, the integration in the environment. We have the engineering aspect, we have the architectural, the conservatory, the heritage, cultural aspect to maintain, and then it's a huge work to try to combine all together to fit in the best situation. The interaction with the surrounding are a lot. We can see that, of course, we have interaction related to the solar radiation. If I have shadowing for other buildings, I have to know that, because on the way around I can make underestimation of the potential. I have to check what kind of material I have all around. If I have heat islands, if I have a lot of heat released by the surface, for instance, of the road and so on. I mean, the interaction with the surrounding are very important to define the building according to the environment, to design the building according to the environment, the wind availability, and so on. But also, there is pollution, because as I said, we are talking about indoor environmental quality. That means I have to take care of what kind of pollution I have outside. Noise pollution, for instance, because that means different system of ventilation, different system with filters for noise, with absorbers, and so on. Electromagnetic pollution, traffic pollution, and so on. The first step in our design, according to the paradigm, NZ paradigm, is demand reduction. Demand reduction means to reduce the requirement. And then we have there two routes. One is on the envelope side, and the other one is on the load management. And the load management, as we say, is also going through education of the user. The envelope passive design is relying on the solar passive design and thermal insulation. Okay, this is possibly designed for the window, but not only. We have to think about reduction of air infiltration. This for the heating. For the cooling, we have the passive cooling, which is going through the solar shading, trying to reduce the solar load on the building itself, and the use of cold surfaces, so we will see better, just to reduce the heat transfer due to solar radiation and radiation. And as I said before, thermal mass activation. Try to use the thermal capacity or your building material to smooth the oscillation. Of course, then we have the efficient system, the third step in the NZEP. Reduce the load as much as possible, use most efficient system, and then cover the needs with renewables. And for efficient system, we can have a large variety. But then when we are looking about, for instance, ventilation, for the reason of indoor environmental quality, we have to look in what environment we are. If the outside air is more polluted than the inside air, when do you take care where we are? Then control natural ventilation is one chance. The other one chance is mechanical ventilation. And then in that case, we have to use high efficiency fan with heat recovery system, for instance. And management is very important, as I said from the beginning. Now, if we look at the efficiency of this system, we can combine renewables with thermal generator. Then we can use solar thermal system using then RES, renewable energy system, but the cost is affordable today only for domestic hot water, let's say. Biomass, that means you can use wood and pellets, boilers. Natural gas is only fossil. It could be used when we cannot use any other things, just to minimize, or use as an auxiliary heater. Electricity, low temperature heat pump, I mean, not direct use of electricity. And this can be both RES and fossil, because the electricity can be produced by power plant, standard power plant, or PV plant, or aeolic plant, and also locally on the building using PV. Then district heating. District heating was called by the Directive 2, but stressing the term RES, renewable energy district heating. Cooling, solar cooling system. We can see again solar cooling system using thermal collector, but with absorption or the absorption chiller. Too expensive. Biomass again with absorption chiller, too expensive. Probably electricity. Then we can run chillers with PV or district heating cooling. Of course, we have to look what we can use, time by time. Then the optimization of the design is just that. Those are options. Lighting and kitchen and domestic hot water appliances are other steps in the design. But then I would like to go close to the end. Then I said we have other three steps: companies, consulting, works, reception, works. For instance, company consulting is very important that when you transfer as a designer the information to the company is going to do the work, the contractor, that the right information has to be transferred. If you don't give the right information, only partial information, nothing will be realized as you wish. Of course, you have procedure in which you are monitoring also the construction and so on to avoid such a problem. Then works, motivate, educate construction works and apply appropriate quality test. It's very important that when you are going to build something different than in the past, as materials, as a system, you have to train the worker because they are not used to do that. They can do it in the wrong way just because they have been not trained about. Facilitate, the last facilitate soft landing. That means, in principle also, we have in the Italian law that the constructor has to deliver a user manual for the building. I never seen that in 20 years. It's very useful. You have in your car what you have to do, what's the time between one maintenance step and the other maintenance step, and so on. Because the building is coming too complex, and then you must know how to use it correctly. Then, finally, as I said, the implementation doesn't the design, let's say, the design procedure does end just when you deliver the building. You have to check that the building is used correctly, and if you have then a trial and error procedure, no? Plan, do, check, act to try if this is all okay and the people has understood how to manage the building and so on, to qualify the building performance, etc. This is very important to avoid that a nice design is not realized correctly, but mainly is not managed correctly. Because one of the most important points in energy savings is to check the control system, because the control system sometimes doesn't work correctly, is wasting a lot of energy and also comfort. It is very easy to correct this, because just the sensor was not in the right place. No, it's very easy then to come to the end. Now, just the last slide, as our host said that we have a task force working on this, on NZEB, it's called MED-ZEB design or NZEB design, and the guideline name, at least up to now, is NZEB design strategies for Mediterranean region, will be divided in two parts. Part one, general design strategies envelope design, almost ready, is going on the final process review and so on. And we are working on the second part, heating, ventilation, air conditioning system design. And we hope this can be a useful tool for our community to go in this direction, to have better building, lower energy cost, and good qualities. Thank you for your attention.
Thank you. Okay, we have 5 minutes for questions. Please proceed to the microphones. Is there any question? Yeah.
First, thanks for the presentation. It's very inspiring because it opens different questions. Could you give your opinion about the possible development of mechanical ventilation in Mediterranean countries? Because this is always a deep question, because typically mechanical ventilation belongs to the, let's say, cold climate country, and also from the perception of the user is something difficult to feel as a technology inside the building. Yeah,
the point is that we have to work on the cultural habit of the final user. Because the point is that, of course, in northern climate was coming because during winter, if you're going to open the window with minus 20 degrees outside, you feel immediately bad and you're going to close the window. But then you need to change the air inside because you feel that it's not anymore good just from your noise. But in our situation, there are I see two possibilities to increase mechanical ventilation use. It's not more related to heating, it's much more related to cooling and noise. Because if you are living in a very crowded area, as for instance, center of Istanbul and so on, the traffic noise is very high. And if you open the window to get some fresh air outside, a lot of noise comes in. If you have instead mechanical ventilation, well designed, not noise mechanical ventilation, then you can combine both. You have clean air and also you have not the noise coming in. On the other side, I said cooling is important. People are coming to us much and much cooling, and then what we have to combine is the cooling with the mechanical ventilation. In that case, again, there is possibility that you reduce the noise inside. Second, that you have only some more humidity control, depends on how you arrange the system, and also better air quality. And we don't have to forget that if you use mechanical ventilation, we can filter the air. We can reduce then pollution from the outside at different level. Then health. We have to start from this point of view. It's not a matter of energy saving, as we think for northern countries, just to avoid to have to much cold air come in without recovering, heat recovering. What we have to think that we have to control the indoor environment. For that reason, I said on the top for Mediterranean and ZEP, we have to say indoor environmental quality as a target.
Okay. Perhaps I can ask, I ask a question. You know, these strategies are very much related with the type of the building. In this guide, we concentrated on residential type building. Would you like to say about those topics?
But residential type of buildings, we have to a bit change our mind because depends again where we are. We have a cultural habit of piece of town when coming from the south of Italy, Sicily, and then the center, historical center is like, let's say, the historical center of Istanbul, like a Casbah, no? Very narrow street and so on, shading each other's, etc. Because the design was an energy-conscious design, just avoid too much the sun coming inside through the windows, small windows, mainly on the north side, not on the south side, etc. White colors, cold paintings, no, already has been invented. Then the point is that depends the route we are looking for. If we are looking for instance, social housing, okay, because we have to think where we have the major construction, then we should have a certain idea in mind, certain services we have to provide, and then also centralized ventilation have a meaning because we have tall building, for instance, 10 floors or 15 floors, etc., with apartment. Then it's strongly related not only to the category of residential. What kind of residential building we are looking for? If we are looking for a nice villa on the seaside, maybe it doesn't make so much sense, no? But depends if you are going to build a large quartier, for instance, residential quartier, then the problem is moving on residential area and then networks, PV networks and thermal networks for district heating and district cooling can have a space if you are designing from the scratch. Then you see there is no a unique answer. Depends strongly on what we are looking at that moment, what kind of building we are going to design.
Okay, thank you.